Amplitude, period, and phase shift. Definition of amplitude. Now, amplitude only applies to sine and cosine. Only sine and cosine. You cannot apply amplitude to tangent, cotangent, cosecant, or secant. The amplitude of a function y equals a times sine of theta and y equals a times cosine of theta, should be an a right here, sorry about that, is the absolute value of a, or the absolute value of a. It's a definition. There's two different ways to do what we're going to do next. There's a technical way, which is behind this blue box, which I'm not going to talk about. If you want to read that yourself and decide to do it that way, you have my blessing. I'm going to show you down here what I'm going to call the alternate method. Let's look at a little example here of how to find the amplitude, period, and phase shift of a function. So this is all based upon the parent graph of y equals sine of x. Amplitude is the absolute value of a, so that's easy. So you take the absolute value of a to find the amplitude. Period. The period for the parent graph for sine is always 360 degrees. Well, because we have different numbers in here for the angle, you have this k multiplied by the angle, and we're subtracting c, it's going to change the period. The period could be longer than 360 or it could be smaller. We're going to figure out how to find that new period. Phase shift, that's a special word which basically means the graph is being translated left or right. So in the past when we had parent graphs, we translated the graph left or right. Now we're doing that, same thing, but we're going to call it phase shift instead of translating left or right. So how do you find the new period and the phase shift? First of all, the new period I'm going to call this little prime symbol. So me saying new period and saying prime is redundant. I'm going to use this prime symbol, meaning that this is a new period. Here's what you do. Make a compound inequality. In the left part of the compound inequality, you put the normal starting period for one period of sine. Now you can start sine anywhere you want. You're going to have the most success if you start it with 0. Wherever you start it, what goes over here on the right side of your compound inequality is going to be the ending of that period. Well, the parent graph for sine, if it starts at 0 degrees, it goes to 360. Take the angle you're given for the problem, and that's, in this case, it's k times theta, theta is a variable, minus c, k and c would be numbers. Put that in the center of your compound inequality. You then use algebra to get theta by itself. Once theta is by itself, then you're going to know what the new phase shift is and the new period is. So we're going to add c to both sides of the equation. That's what we're going to do first. If we add c to 0, we get c. If we add c to 360, we get 360 plus c. If we add c to the middle, the minus c and the plus c cancel. Then to get theta by itself completely, we want to get rid of this k times theta. So we're going to divide c by k theta by k, and 360 plus c divided by k. I should have degree symbols for each of these. Once you get it in this form meaning that you have theta by itself, this will tell you how to find the phase shift in the new period. To find the phase shift, you compare the number we started with, which is 0, to this number here. Comparing means subtracting. So the phase shift is going to be c over k. If you always start your period at 0 degrees, which I always will, to find the phase shift, it's always this number on the left. So I'm just going to draw an arrow right there. To find the new period, if you think about this logically, the period was starting at 0 and going to 360. So you take the end minus the beginning. 360 minus 0 is 360. Well, our period is ending at this, and it's starting here. See, we were starting at 0 and going to 360, and now we're starting at c over k and going to 360 plus c over k. So to find the new period, take the end of the period minus the beginning. Take the end minus the beginning. Sorry for all these arrows, they're not real clear. If you subtract those, they already have common denominators. So you would have Combine the c's, and you end up with 360 degrees divided by k. Need my degree symbol there. That's how you find the new period and phase shift for a function that is sine and it's not the parent. Let's do the same thing here for cosine. I'll show you how this works. If you want to find the amplitude, just the absolute value of whatever you're multiplying by cosine. If you want to figure out what the new period is in the phase shift, make a compound inequality, where the center of it is the angle you're given, where the left is the normal beginning and ending of one period of cosine. Cosine's period is 360 degrees, the parent graph. Then you get theta by itself. So if you add c to the left, the middle, and the right, then divide all the terms by k, you're going to get this. Then to find the phase shift, which we'll call PS for phase shift, you just take where this is starting. It was starting at 0. Now it's starting at 0. Or pardon me, now it's starting at c over k. That's a phase shift. To find the new period, you take where it's ending minus where it's beginning. So 360 plus c over k minus c over k, which gives you 360 degrees divided by k. If you do the same thing for tangent, the amplitude does not exist. Amplitude is a term reserved for sine and cosine, so the amplitude is none. To find the new period in the phase shift, you take one period of tangent. We're always going to start at 0 because it makes it easiest. The period length for tangent is 180 degrees, so it's not 360 like sine and cosine. You get theta by itself by adding c to both sides and dividing by k. You get this hot mess. So then the new period and the new phase shift is just the beginning once again. And the new period, you take the end, which is this, minus the beginning, which is what this says right here, and you get 180 degrees over k. The directions state the amplitude, period, and phase shift for each function. So number 1, we have y equals 10 times tangent of 4 times theta. So the angle for this problem is 4 theta. Amplitude is easy. Tangent doesn't have an amplitude. That's a word reserved for sine and cosine only, so there's no amplitude. To find the new period, that's period prime. And to find the phase shift, you do the following. You make a compound inequality, putting at the beginning and the end one complete period of the parent graph. Tangent's complete period is 180 degrees, so I'm going to write it from 0 to 180. Sorry about that. And then you put in the center of the compound inequality the angle that you're given. The angle we were given was 4 theta. Then get theta by itself. To do that, you're currently multiplying it by 4, so you're going to divide each term, that's the left, the middle, and the right, by 4. 0 divided by 4 is 0. 4 theta divided by 4 is theta. 180 degrees divided by 4 is 45 degrees. To find the new period, you take the end minus the beginning. Our graph, one period is going to start at 0 and go to 45. So 45 minus 0 gives us a new period of 45 degrees. To find the phase shift, it's just this beginning number. It didn't shift at all. It started at 0 originally, and it's still starting at 0. Done. Number 2, we get y equals 243 times sine of the angle 15 theta minus 40 degrees. To find the amplitude, it's simple. You take the absolute value of A. A is 243. Its absolute value would be 243. Yes, you have to show that work. To find the new period and the phase shift, take the angle that you're given, 15 theta minus 40, put that in the center of a compound inequality, putting on the outside the beginning and end of one period of the parent graph. Sine's period goes from 0 degrees to 360. Then use algebra to get theta by itself. If I add 40 to the left, to the right, and to the middle, we get this. If we divide each term by 15, we get this. Don't use decimals, please. Those fractions reduce to 8/3 and 80/3. So the phase shift, we were starting at 0 degrees. Now we're starting at 8/3. So our entire graph has shifted 8/3 of a degree. To find the new period, well, we were starting at 0 and going to 360. Now we're starting at 8/3 and ending to 80/3. So we take the end minus the beginning. This technically should be degrees. They already have common denominators. That's 72 divided by 3, which reduces to 24 degrees. So this graph, which used to extend 360 degrees so it repeated itself, now repeats itself every 24 degrees. So it is really squished. Number 3 is cosine, 2 times cosine of 4 theta. Put the angle in the middle, 4 theta. Put the beginning of the parent graph of cosine and the end of one period. It goes from 0 to 360. Get theta by itself. Divide each term by 4 to do that. It goes from 0 degrees to 90 degrees. The amplitude is the absolute value of A. The absolute value of 2 is 2. To find the new period, you take the end, which is 90 degrees, minus the beginning, which is 0, which is going to give you 90 degrees. To find the phase shift, it's 0 degrees. It was starting at 0, now it's starting at 0 again, so it didn't shift at all. The next set of problems having us doing what we just did in the first 3 examples backwards. Write an equation for the sine function with each amplitude, period, and phase shift. So here's what you do. You make a compound inequality like so. At the beginning you put the phase shift, in the middle you put theta, and on the right you put the phase shift plus the period. So our phase shift, we are told, is 60 degrees. Put theta in the middle. On the right you put the phase shift, which is 60 degrees, plus the period, which it tells us that period is 720 degrees. Your goal then is to manipulate this so that it begins with 0 degrees and ends with 360, because that's how sine typically is, the parent graph. It goes from 0 degrees to 360. So using algebra, we're going to get 0 on the left, where the 60 is. We're going to subtract 60 from the left, the middle, and the right. Then, to get 720 degrees to be 360, you have to ask yourself this question. What can we multiply by 720 to get 360? In other words, 720 times x equals 360. I know it seems like a silly step, but please do it, because not all the problems are this simple. Take an x by itself, you divide by 720, that reduces to 1/2. Therefore, to get 360 degrees on the right, we're going to multiply each term, 0, theta, 60 degrees, and 720 by 1/2. And we're going to get this. 0 times 1/2 is 0. Theta times 1/2 is theta over 2. 30 times 1/2, 60 times 1/2 is 30. And 720 times 1/2 is 360. So your answer. Write an equation of the sine function. So it's y equals plus or minus 3. I'll get to the plus or minus in a minute. 3 comes from the amplitude. 3, 3. Times sine, the direction set is sine function, and then the angle that you just found. We just found the angle of theta divided by 2 minus 30. That's what goes in the middle. The reason this is plus or minus, the amplitude is the absolute value of something. So it could have been a negative 3, whose absolute value is 3, or it could have been a positive 3, whose absolute value is 3. We don't know which it is. So when you write this, you have to write plus or minus. Let's do another. This next one is in radians. So to write your compound inequality, you write your phase shift on the left, right here, put theta in the middle, put your phase shift plus your period over here on the right. Since we're talking about radians, the period length of the parent graph for sine is 360 degrees, or 2 pi radians. So we're trying to manipulate this compound inequality so it's 0 on the left and 2 pi on the right. To get 0 on the left, I'm going to add pi over 4 to the left, the middle, and the right. On the left, if you add it, you get 0. In the middle, those are not like terms, and on the right, the pi over 4's cancel. Now, how do we get 3 pi over 2 to become 2 pi? We have to multiply it by some number to get that. I don't know what that number is. So you write 3 pi over 2 times some number x equals 2 pi. To get x by itself, you're going to get 4/3. Let me just show you real quick how you get that. If you take 2 pi times the reciprocal of 3 pi over 2, you get 2 over 3 pi. Pi's cancel. 2 times 2 is 4. 3 times 1 is 3. That's why it's 4/3. 0 times 4/3 is 0. 4/3 times theta is 4/3 theta. 4/3 times pi over 3, times pi over 4 is pi over 3. And then 3 pi over 2 times 4/3 is 2 pi. So our answer is y equals plus or minus the amplitude, which is 1/2, times sine of the angle, which we found is 4 pi over 3 plus pi over 3. Next set of problems says the same thing as the previous ones, but it says cosine. Do it the same way, but your answer is going to say cosine instead of sine. Compound inequality. Put the phase shift on the left, theta in the middle, phase shift plus the period on the right. And this should be 630 degrees. Manipulate the compound inequality till you get 0 on the left and 360 on the right. I'm going to add 90 to the left, the middle, and the right. And then I've got to figure out what do I multiply 630 by to get 360. Using some algebra, I'm going to get 4/7. So I'm going to multiply the left, the middle, and the right by 4/7. That gives me this. And this should be, once again, degrees in there. So my equation, y equals plus or minus the amplitude of 100 times cosine of the angle, 4 pi over 7 plus 360 divided by 7 degrees. Next one, this was in radians. Compound inequality, put the phase shift on the left, theta in the middle, phase shift plus the period on the right. Add pi over 3 to the left, the middle, and the right, so that I have 0 on the left. And then to try to get 2 pi on the right, I'm going to take the equation 3 pi over 4 times x to get 2 pi. To get x by itself, I'm going to multiply both sides by 4 over 3 pi, which is going to give me x is 8/3. So I multiply 8/3 times each of these terms, I get this. So therefore my equations, y equals plus or minus my amplitude of 1, cosine of the angle, 8 pi over 3 plus 8 pi over 9. We're supposed to graph the function and its parent. We shouldn't have had to graph the parent graph for sine. So let's figure out how to graph this function, 1/3 of sine of theta over 2. Essentially, we're just going to redo what we just did with our notes. So we have to know what A is, not the amplitude, but we have to know what A is, the period, and the phase shift. So what we do, we write a compound inequality with the left being where sine normally begins and ends, or normally begins. The right side where it normally ends, 360 degrees, and the angle we're given in the middle. Then you get theta by itself. Multiply each term by 2, and we get 0 degrees is less than or equal to theta, which is less than or equal to 720 degrees. So A is 1/3. That's not amplitude, but it's A. It's the coefficient. The new period, period prime. It's 720 minus 0, which is 720. That's the end minus the beginning. And the phase shift is 0. That's the number from the beginning. Now we make a table. Here's how this table works. Here's how the table works. You're going to have to make these tables when you do your homework, tests, and quizzes. Make a column for x and y. That's for the parent graph. Let's run through that real quick. So when we're going to graph the parent graph for sine, we usually count quadrantal angles. 0 degrees, 90 degrees, 180 degrees, 270, and 360. Sine of 0 degrees is 0. Sine of 90 is 1, 180 is 0, 270 is negative 1, and 360 is 0. If you forget how to do that, you just draw a little picture, and you figure out what R1 y and r are in those locations. You write those down and you write the ratios. I think you know how to do that fairly well at this point. To find the points for the new graph. So those are points we're going to have for the parent graph for sine. To find points for y equals 1/3 sine of theta over 2, this is how this works. You take your new x value, that's what x prime is, take the new period divided by the parent's period. Multiply that by x, add in the phase shift. So in this case, we found out that the new period is 720, the parent period for sine is 360 degrees, and the phase shift we found is 0. That simplifies to 2x. That means we're going to take each of the x values that we have written over here, put them into this to figure out the new x value. So 2 times 0 is 0. 2 times 90 is 180. 2 times 180 is 360. 2 times 270 is 540. And 2 times 360 is 720. These should all be degrees. I apologize for that. To find the new y values, the y primes, you take a times y, that's not amplitude, that's a, and then add in your vertical displacement, which we have not talked about yet, but vertical displacement essentially is your vertical translation, which we don't have any in this problem. So it's 1/3 times y plus 0, which simplifies to 1/3 y. So we take each of these y values, plug them into this to figure out the new y value. So 1/3 of, sorry about that, 1/3 of 0 is 0. 1/3 of 1 is a third. 1/3 of y is 0. 1/3 of -1 is -1/3. And 1/3 of 0 is 0. We're supposed to graph the parent graph, y equals sine of theta, and the graph for this problem, y equals 1/3 sine of theta divided by 2. We now have a list of ordered pairs in which we can do that. So let's check out our graph. When you're doing this, the first thing you have to decide is how you're going to label your x-axis and your y-axis. Since my y values go from 0, 1, 0, -1, and 0 from my parent, and 0 and 1/3 and -1/3 from my graph, I made sure that I counted every one dot was a third. So every 3 up would be 1. So that means 3 down is -1. My x-axis, I have to count all the way to 720 degrees. So I counted every 4 spaces is 180. You can do this in lots of different ways. Your goal is to make it so you don't have a lot of guesswork. So I meant every 4 spaces is 180. You could easily do every 2 spaces is 180. This blue graph is the parent graph. There's a dot at 0, 0. There's a dot at 180. Pardon me. The red graph is the parent graph. There's a dot at 90 degrees, 1. There's a dot at 180 degrees, 0. At 270, -1. And at 360 degrees, 0. I then connect those points along what the parent graph looks like using a smooth curve, like so. When I do this, I want to put at least 2 periods, so I know what this looks like clearly. That's why I extended this like so. Now this other graph that I'm doing, the blue one, which is y equals 1/3 sine of theta, I had a point at 0, 0, at 180, 1/3, at 360, 0, at 540, -1/3, and then at 720, 0. Since I know what the parent looks like, I then connect those, concave up and then concave down, like so. If I zoom out a little, you don't have to go as crazy as I did. I drew sine the entire way, as far as I could draw this graph. Just do at least do 2 periods, let's say, for the parent. And then my y equals 1/3 sine of theta over 2, you can see in blue. I color-coded them, so you can do the same if you would like. Since I have 2 graphs on the same picture, this one I wrote in blue because the curve is blue. This one I wrote in red because the curve is red. Second one, we're supposed to graph y equals 3 times cosine of theta, also the parent graph. So we take the angle we're given, which is theta, put it between the normal and ending point for cosine, which is 0 to 360, and get theta by itself, it already is. So that means that our a is 3, that's the coefficient of cosine. The new period, period prime, Take where it ends minus the beginning. 360 to minus 0 is 360. And the phase shift is 0 degrees. That's the beginning. Sorry, I got interrupted, so this might be incoherent. Anyhow, so our phase shift is 0, our new period is 360, and our A is 3. So the only thing different from the parent is that A is 3, where it was not, it was 1 in the parent. Write down your ordered pairs from the parent graph. X and Y represent the parent graph. You count by 90s. Cosine of 0 is 1, cosine of 90 is 0, cosine of 180 is negative 1, cosine of 270 is 0, cosine of 360 is 1. If you forget how to do that once again, let me know and I will show you in more detail. To get the new x value, you take the new period divided by the parent's period, add in your phase shift. Both the new and old period are both 360. So if you divide those, you get 0. You divide those, you get 1. And that means our new x values don't change from our parents. To get the new y values, y primes, you take a times y plus your vertical displacement. Vertical displacement is 0. Once again, we're going to talk about that more in the next section, vertical displacement. So you take all of your y values and you triple them. 3 times 1 is 3, 3 times 0 is 0, 3 times negative 1 is negative 3. 3 times 0 is 0, and 3 times 1 is 3. Here's what your graphs look like. The red graph is the parents, y equals cosine of theta. We had a point at 0, 1. We had a point here at 90, 0, at 180, negative 1, at 270, 0, and 360, 1. I drew that for a couple periods. Our new graph, we had a point at 0, 3. 90, 0, 180, negative 3, 270, 0, and 360, 1. So I draw that. Red is the parent, and blue is our new graph. Number 3 is y equals negative 6 times secant of the angle 2 theta plus pi over 2. Since this angle here, since we're adding this number and that number doesn't have a degree symbol, it means we're in radians. So instead of going 0 to 360, we're going to go 0 to 2 pi. So we start at 0, we go to 2 pi, put the angle in the middle, and we try to get theta by itself. The parenthesis that you see here is an error and doesn't need to be there. If we subtract pi over 2 from the left, the middle, and the right, like so. On the left, this should be not a 0, but a negative pi over 2. To subtract 2 pi and pi over 2, you need to get common denominators. So it'd be 4 pi over 2. 4 pi minus 1 pi is 3 pi over 2, which gives us this. To get theta by itself completely, then, you would multiply each term by 1/2. That would be negative pi over 4 on the left, 3 pi over 4 on the right. Once theta is by itself, write down what a is. It's negative 6. It's the coefficient. The new period, period prime, take the end, 3 pi over 4, minus the beginning, negative pi over 4. Subtracting a negative is like adding a positive. It's going to give you 4 pi over 4, which reduces to pi. So instead of our period being 2 pi, that's our parent, our new period is just pi, so it's cut in half. Phase shift, that's the beginning here, which is negative pi over 4. Let me make our table. A little more complicated because we're using radians. Counting by 90s or pi over 2s, you get 0, 1 pi over 2, 2 pi over 2, which is pi, 3 pi over 2, 4 pi over 2, which is 2 pi. And then the corresponding y values that go with it. Secant of 0 is 1. Secant of pi over 2 is undefined. Secant of pi is negative 1. Secant of 3 pi over 2 is undefined. And secant of 2 pi is 1. And once again, to find those numbers, you just make a little, kind of like a unit circle. You mark your quadrantal angles. You write down what x, y, and r are in those places and figure out what secant is of that. And that's how you get those numbers. So our parent graph, we can see there, is going to be those numbers. Then, to find our new x values, take your new period, which is pi, divided by the parent's period, which is 2 pi, times x, plus your phase shift of negative pi over 4. Pi divided by 2 pi is a half. Get our new x values, we're going to be cutting it in half and then subtracting pi over 4. 0 cut in half is 0. 0 minus pi over 4 is negative pi over 4. Half, the next one, half of pi over 2 is pi over 4. Pi over 4 minus pi over 4 is 0. Then we have pi times a half. It's 2 pi over 4 minus pi over 4. If you get common denominators, subtract those, you get pi over 4. Then we get half of 3 pi over 2, which is 3 pi over 4, minus pi over 4, which is 2 pi over 4, which is pi over 2. If you need help with these fractions, let me know and I'll sit down with you and help you. Then finally, half of 2 pi is pi. Pi is a fraction with 4 as the denominator is 4 pi over 4. Subtract pi over 4 from that and you get 3 pi over 4. And our y values, take a times y, that's negative 6 times y, plus your vertical displacement, which we don't have one, and you get negative 6y. So you get 1 times negative 6, undefined, 6, undefined, and negative 6. Here's what your graph looks like, and then y. Let me explain this. So let's try to focus on what's in red first. That's the parent graph. Secant of 0 is 1. Secant of pi over 2, which is 90, is undefined. Secant of 180 or pi is negative 1. And then secant of, oh shoot, the bell rang. Take a moment and look at this graph, and I think you'll see how these things match up. I drew a couple periods for the parent and a couple periods for y equals negative 6 secant of 2 theta plus pi over 2.